Hello, lesson 13, and let's start a second part of our module, Construction Applications. And here we'll understand about building construction survey. Construction surveys provide for the horizontal and vertical layout for every key component of construction project. Only surveyors experienced in both project design and appropriate construction techniques can accomplish the layout for line and grade. A knowledge of related civil design is essential to interpret the design drawings effectively for layout purposes. And knowledge of construction techniques is required to ensure that the survey layout is optimal for line and grade transfer, construction scheduling, and ongoing payment measurements. Global positioning system techniques are now also being implemented successfully in areas of moderated density. And the survey method chosen by a survey manager is usually influenced by the cost and the reliability of the point positioning. All buildings must be located with reference to the property limits. Construction survey for a single-story building may only entail survey layouts for the building footing and ground floor elevation, and the contractor can tie in the rest of the building components to the footing and the first floor elevations for both line and grade. Of course, site grading surveys will also be required in most circumstances. So here you can see a block plan which illustrates the general area of construction site. And here you can see a site plan which gives exciting and proposed elevations, key building dimensions, 16 by 20 meters, setbacks from front and side line, 5 meter and 7.5 meter respectively, parking area, walks, and so on. Here you can see a ground floor plan which gives the basic dimensions as well as first floor elevations and column location. Here you can see an elevation and section, both showing footing elevation, first floor elevation, and roof elevation. The survey sets up the property lines as shown on the site plan. The building corners are then set out by measuring the setbacks from the property lines. After the corners have been staked, diagonal distance on line or offsets can be measured to verify the layout. That is, for the building shown 16 to 20 meters, the diagonal should be 25.61 meter. Once the corners have been laid out and verified, their offsets and better boards can be laid out. Here you can see a location of better boards and string lines used for control of an building. The better boards and string lines are usually set at the first floor elevation. Better boards and string line. And this is the corners of the building. This plan also shows the location of each string length and each building wall footing. This is a combination of theodolite and level that can be found on many small construction sites. This theodolite level is not as precise as many of the instruments previously introduced in this text. Its precision is well suited for small construction sites, where the instrument sites are relatively short, typically less than 50 meters. Here you can see a small block beginning to excavate. Here you can see the steel work for a single-story commercial building. And the column shown have been bolted to the footing anchor bolts previously laid out by the surveyors. This is a connection of column to footing by use on anchor bolts. A template can be used to properly align the bolt pattern to the column center line. The tolerance is usually set at 1/8 inch from 3 to 4 millimeters for each set of column bolts, with the overall tolerance for the length of the building set at 1/4 inch. This is 6 millimeters. The column can be plumbed with the aid of a theodolite. But for single-story construction, the column can be satisfactorily plumbed with a spirit level, carpenter's level, so vertical alignment of the wall using theodolite. Once the steel is in place, the surveyor can mark the column a set distance above the floor grade. In North America, the offset marks are set at 4 or 5 feet above the floor slab. Masonry or concrete walls can be checked for plumb by setting the theodolite on an offset line, sighting a target set on the same offset line, and then checking at parts of the wall or concrete forms with the aid of pre-cut offset boards, either held against the wall or nailed directly for the form. Construction lasers and electronic levels. The word laser is an acronym for light amplification by stimulated emission of radiation. Now green beam visible lasers are now used outdoors as well as indoors. In building construction, a rotating instrument defining a horizontal and vertical plane is used to control the construction. The visible beam laser instrument can be used in darkness areas, indoors without a beam detector, as the now visible beam itself can be used as a reference line. When false ceiling are installed, for example, the column-mounted rotating laser beam makes a laser mark on the ceiling hanger as it streaks its surface. The ceiling hanger is then marked or bent at the laser mark, ensuring a quick and horizontal installation for the ceiling canals and the subsequent ceiling tiles. Our large indoor areas. Many rotating lasers and electronic levels can be battery driven with 10-hour operations requiring overnight recharging. These instruments are also self-leveling when first set up to within 4 degrees of level. These automatic instruments will stop rotating if knocked off level. The rotating speed can be varied from stop to 420 RPM. So you can see electronic level and marking vertical control and 4 marks on steel column anchor bolts. And here you can see self-leveling level, automatic rotating level, 300 minutes range with leveling rod and laser detector. This instrument itself can be set up on both threaded and bolt type tripods and on any flat surface as well. The accuracy of this instrument is 1/8 inch at 100 feet and 3/16 inch at 200 feet, with decreasing accuracy up to the limit of about 600 feet. The adjustment of the instrument can be checked by comparing results with a good quality automatic level. If the electronic level is off by more than 1/8 inch in 100 feet, it is returned to the dealer to recalibration. When used for setting 4 feet marks, 1 meter marks, or other floor reference marks. This technique is quite cost effective. Very important, it's very effective. If a level and rod are used for this purpose, it will be take 2 surveyors, instrument and rod, to do the job. When the electronic or laser level is used, the survey crew is reduced to just 1 surveyor. This eliminates communications and the chance for communication errors, and according to some reports, has resulted in a 50% increase in work accomplished alone, with a 50% decrease in workforce. Here is rotating laser controlling horizontal and vertical building component. This is a spectra pressure rotating laser level and electronic receiver being used here to set concrete forms to the correct elevation. And this is a rotating laser level position to check plumb orientation of construction wall. This situation illustrates the ease with which the worker can check concrete footing prior to the concrete block wall construction. With using of Laser 300. About multi-story construction, it demands a high level of precision from the surveyor. As the building rises many stories, cumulative errors could cause serious delays and expense. Multi-story columns are laid out by intersecting precisely established column lines, and the distance between columns are then checked in all directions. A theodolite signed on pre-marked column centered or on the column edge checked for plumb or verticality. Column edges are signed from stations set on offsets a distance of 1/2 the column width. Shim plates up to 1/8 inch are permitted in some specification when one is plumbing columns that are mounted on anchor bolts. These anchor bolts. Elevations are usually set 2 floors at a time. The elevations can be carried up or down installed stairs, but differential leveling using a well-adjusting level. But many building surveyors prefer to transfer elevation upward by taking simultaneous readings from properly tensioned, fully graduated steel tape, which can be hung down from the upper floor. The lower floor surveyor set up with a known height of instrument takes a reading on the suspended steel tape. At the same time, the second surveyor, who has a level, set up a floor or two higher, also takes a reading on the tape. The difference in reading is added to the lower height of instrument to give the upper height instrument. Temporary benchmarks are then set on the upper floor. Horizontal positioning. Horizontal control can be extended upward by downward plumbing through small 6-inch square through floor ports onto the lower floor control stations or onto marks offset from control station. The plumbing operation is often accomplished by using optical plumb. This is a precise optical plumb in 100 meter for a single measurement equal 1 millimeter using a coincidence level. This is azimuth clamp, leveling screw, you know this nadir telescope, focus knob, zenith telescope, and tabular level VL. Upward plumbing is dangerous, as material may be accidentally discharged through the floor port onto the surveyor below. In addition to using optical plumb, the surveyor can use heavy plumb bob. You know what is the plumb bob. With swing oscillations dumped in oil or water. New layouts are constantly checked back to previously set layout points for both line and grade. All angles are doubled. Face right and face left. And all distance tolerance are in the 5 millimeter range. Upper floor control is checked back to control previously set on lower floors when it becomes necessary to transfer control to higher floor from the ground for steel structures. The survey work must be done early in the morning or on cloudy days, so that the sun cannot hit and thus deform various parts of the structure, causing an erroneous layout. This illustration illustrates the case where a theodolite is set up by interline vegan line in between targets. Set on adjacent structure. This is a target on permanent marks. These permanent targets were originally set from ground control before the project started. An alternative to this technique would be to set up on a control station located on a high building, site a permanent target on another building, and then transfer this line down onto each new floor on the building as it is constructed. Horizontal alignment, reference azimuth point. A survey station located on an upper floor by downward optical plumbing to a previously set control mark. Alignment is provided by citing reference azimuth point. Point of known position, and we already know this. And knowing the coordinates of the instrument station and the coordinates of at least two reference azimuth points, the surveyor can quickly determine the azimuth and distance to any of coordinated building layout point. A third reference azimuth point is cited to provide an accuracy check. If programmed total station is being used, the coordinates of the layout point, the reference azimuth points and the instrument station can be loaded to the data collector. And with the required layout distances and angles, polar tie being calculated automatically. So optical plumbing combines with reference azimuth point, steel type and theodolite for polar layout. About horizontal alignment, free station. Free station can be used for most layout surveyors, not just building survey, and has several advantages. The theodolite can be set up to avoid obstacles, or total station can be set up. Setup centering errors are eliminated. Further control stations are required, and the setup station can be located close to the current layout work. The layout work is greatly accelerated if total stations are employed. Here you see illustration of resection techniques being used to provide the coordinates of theodolite station. In this case, the theodolite or total station is set up at any convenient location, called a free station. Angles are then taken to a minimum of 3 coordinate control stations. A fourth control station could be taken to provide a second computation of the instrument stations as an accuracy check. In both angles and distances are to be taken to the control stations. Only 2 or preferably 3 stations are required. By using trigonometric relationships, To solve these resulting triangles, the coordinates of the instrument station are computed. Most total stations are now programmed to solve resection problems. Once the coordinates of the three stations are solved and the total station is back-sighted to a known reference point, the total station programs can then compute the polar ties to any layout point. So you understand about location and alignment of the instrument by resection for free stationing. And next topic will be about using of beam model in layout. So about combination 3D building information models, beam, robotic station, laser guidance, etc. Thank you, and understand, for a civil engineer there is no such things as a little mistake. Bye.